Hi, M214. Today we are here to review some Chapter 8, which was our chapter on polygons. The first question we want to ask is, what is a polygon? What does it mean to be a polygon? A polygon is a multi-sided figure, that just means it has more than one side, with the following properties. Property number 1 says the figure must be closed. Okay, this right here, that's not closed. That means that at all corners, at all vertices, the sides must actually meet. You cannot have a gap or an opening like that one. Okay, number 2, the sides have to be segments, so no curves. Okay, remember a segment has endpoints and it is straight in between. It is part of a line. This is a curve, therefore not a segment. Therefore, this figure is not a polygon. Lastly, remember the sides cannot cross one another. So maybe you can see this here, that the sides are crossing. It's almost like the bottom of this triangle, if you will, has been folded and folded up, and now they are crossing each other. Okay, you cannot have sides that cross one another. Okay, so a quick recap. What is a polygon? In all of these examples here down below, okay, all of the figures are closed, the sides are segments, there are no curves, and the sides do not cross one another. So first step, what is a polygon? Completed. Okay, so next let's remind ourselves how to name a polygon. So since this is review, I am going to talk through this pretty fast, but 3 sides, we know that that is a triangle. 4 sides is a quadrilateral, but remember, a quadrilateral could be split up into a rhombus or a trapezoid or even a rectangle, a kite, a square. There are many different types of quadrilaterals. 5 sides, that's a pentagon. 6 sides is a hexagon. I think I have a hexagon right here for you. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. And at that point, that's where I drew this line right here. That's where we stop having fancy names. What do we do about the ones after a decagon? What about an 11-sided figure, a 12-sided figure, 13, and so on? So if a figure has 15 sides, we don't have a fancy name. We're just going to use the number, a dash, and the word gon. So a 15-sided figure for our class is going to be a 15gon. A 27-sided figure is now a 27gon. A 99-sided figure would become a 99gon, and so on and so on and so on. Okay, real quick, let's add one more vocab word in here, and that is, what does it mean for a polygon to be regular? Okay, so let me start with the hexagon first. This is my hexagon. It's got 1, 2, 3, 4, 5, 6 sides. If you look at the markings, the first thing I've done is I've marked all 6 sides equal. That is the first property of being regular. It has to be equilateral. Second, all of the angles have to be the same as well. So if the angles are equal, that's equiangular. So if a hexagon or a different polygon is both equilateral and equiangular, then yes, it's regular. Okay, now look at this pentagon. So 1, 2, 3, 4, 5. Yep, that's a pentagon. Is this pentagon a regular pentagon? Your answer should be a big fat no. Clearly, these sides are not all equal. The angles aren't either, but as soon as I see the sides aren't, that's enough for me to say no. This pentagon is not regular. It is still a pentagon. It is just not a regular pentagon. Okay, so topic 2, vocab associated with polygons in terms of naming it and whether or not a shape is regular. Check. Okay, so the last part of this video is we have to talk formulas. What formulas did we know? What did we use? We used a formula to find the sum of the interior angles in any polygon. So for example, what's the sum of the angles in a pentagon? What's the sum of the angles in a decagon? Etc., etc. I think most of you will remember the formula that looks something like this. The sum of the interior angles is equal to n minus 2 times 180 degrees. Okay, so let's do one quick example on how to find the sum of the interior angles in a heptagon. So the first thing we've got to realize is that a heptagon is a 7-sided figure. So 7 sides means that n is equal to 7. That also means that we're going to take a 7 and plug it into our equation for n. So the sum of the interior angles in a heptagon is 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 is 900. So the sum of the interior angles in any heptagon, regular, not regular, doesn't matter, the sum is 900. Okay, last example. Again, this is just review, so I'm trying to do this quick for you guys. Solve for x in the figure below. Okay, so the first thing we need to do is decide what figure is it. So 1, 2, 3, 4, 5. I'm looking at a 5-angled, 5-sided figure. That makes it a pentagon, but more importantly, n is equal to 5. Okay, so just like the last example, since n is equal to 5, I take 5 and I plug it into my formula. So 5 minus 2 is 3. 3 times 180 is 540 degrees. But we're not done here. I didn't ask you to find the sum. I asked you to find one particular specific angle. If all the angles were equal, I could just take that 540 and divide it by 5. But they aren't all equal. They're all different. So now I need to subtract each of these angles off of 540, and what's left will give me the measure of x. So as you can see, I started with 540, I subtracted off 142, 98, 76, 91, and I was left with 133. Final answer, x equals 133 degrees.